All right, so one of the ways that we use completing the square is we use it with the square root property to solve a quadratic equation. The other way that we're going to use completing the square, and this may actually be a slightly bigger deal, is to get a quadratic function that's in that general or standard form and then switch it into vertex form. If we learn how to do this mathematically, then we don't have to worry about memorizing the negative b over 2a and using that and going from there. And yes, I will expect you to be able to change a quadratic function from general form into vertex form. So let's see how that's going to look. So the first thing I'm going to do, just like I did when I was solving quadratic equations, is I'm going to move the constant to the other side. So I'm going to add 6 to both sides on this first part. And then I'm ready to complete the square with the stuff over here. So to do that, I'm going to add a blank to both sides. And again, the pattern of a perfect square trinomial is what we're looking for. So we're going to take that middle term, its coefficient, take half of it, which will take that 4, and then square it. So that'd be 16, which means that also gets added to the other side. Now, this is a perfect square trinomial, and because we completed the square, it's always going to factor the same way. It's going to be x, and then half of that added to it, so plus 4 squared. And on the other side, we have 6 plus 16, right? That's 22, and they can't be combined with y because they're different. They're not like terms. Now, in solving by completing the square, this is where we would take the square root of both sides and yada, 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 blah, 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 blah. However, when you're getting it into vertex form, we're almost already there. Vertex form is basically y equals a times x minus h squared plus k. All we really have to do is get the y by itself. We're not trying to solve for x here, we're just trying to get the y by itself. So to do that, all I have to do is subtract 22 from both sides. And this is now in vertex form. My a is 1. My h, which is the x-coordinate of the vertex, remember it's x minus h, so we have to change the sign on it, would be negative 4. And my y value is negative 22. So if I wanted to graph this thing, I would pick some numbers around my vertex, negative 4, negative 22, plug them in for the x's, get back the y's. Now, let's look at the second problem. It's the same process. It's a little bit more difficult because we have a coefficient on the x squared. So like we did in the solving, we have to get rid of that first. So we're going to divide everything by 3. That includes the y. Going to move the constant to the other side. We're going to complete the square by adding a blank to both sides, and then filling that blank with what will make this a perfect square trinomial, which is half of 4 squared. This is now a perfect square trinomial, so it factors. Over here we have y over 3, and then we have 4 plus 11 thirds, which we would need a common denominator, so that would be 11 thirds plus 12 thirds, which is 23 thirds. Now we need to get the y by itself. So this is a two-step process. I'm going to undo the 23 thirds. By subtracting it. And then I'm going to get the y by itself by multiplying everything by 3. Now when I multiply y over 3 by 3, it just becomes y. And when I do the 3 to the other side, the 3 cannot go inside the parentheses because the square would have to happen first. So it sits outside. And there's my a value. It's the same as the a I started with. And then I also have to remember to multiply this by 3 as well. So that would be negative 69 over 3, which is negative 23. So my vertex here would be negative 2, negative 23. So that is how you use completing the square to get a general quadratic function into vertex form.